Yeah. Yeah, much better. Much better lighting. Okay, and I should stay here. So here's the plan for today. I'm thinking that we will take that, what is that, Sonnet game that we started working on. It's like 5 or 10 minutes worth of work to wrap it up really and actually have a game that we can play. So I think here's my idea and plan. Today, after your demos are over, we can start working on it. And after I get a chance to talk about the ampersand thing. Yeah, that's really cool. So after that, we'll work on this Sonnet game. And my plan is, once we've got that working, I can show you how to turn that, add the right kinds of bells and whistles to make it look like just a Unix game that goes out with the Linux package. Like it's installed in your bin directory when you boot it up. And you can say Sonnet, but it's not just installing the game there, but there are certain Unixy, Linuxy idioms that programmers use. The kinds of ways in which these programs ought to behave, right? You can be an expert C++ programmer, but it'll take a couple of weeks to actually figure out the ways in which the interfaces of these commands are built, right? In terms of the verbosity and what kinds of defaults are used for different things. This takes a couple of weeks to pick up, or maybe many years, I don't know, right? But I'll show you how you can turn this command into something like that, because no matter whether you're going to use it now or later, it'll be useful. And the other reason I wanted to talk about that was there's something called argc and argv, which you're probably dealing with in quest number 2 or 3, right? With Limerick. There's something called argc and argv. Have you in your quest, have you encountered that? Okay, so we'll get a chance. We'll get a chance in the process of turning this Sonnet game into a Unix command or a Linux command or command line command on your Mac or Windows. Just run it on command.com, right? So the DOS prompt. It'll be fun. You can also turn it into a GUI game. So that's so it's very easy. Okay, so we'll do that. Is my plan, and I think that's probably enough for the rest of the class. If not, we'll just take it to the next level and add more. Okay, Ong and Vivian, yeah, welcome to class. So we just went over the plan. Yeah, hey, Zach and Helen, also welcome. Great. Okay, so how about this? Yeah, now that everybody's here, who wants to demo? Right, I think. Who wants to go first? Okay. And the moment that nobody else wants to demo, we'll just go on to this program. This Sonnet program. We'll just click on the online GDB link. We'll fork the code and we'll start editing it. Okay. And one of you is going to pick it up. Just make a name. There's a couple of you didn't demo last class, yeah? But I thought you had something. If you had something and you wanted to show, yeah, this is your chance. Otherwise, we'll just move on. How about that? Is that a good idea? If you don't want to, if you don't have code that you want to share right now, that's fine. Okay. Is that you have something to demo?
Yeah.
Okay, great. So Raj is going to share the screen. Okay. And I think, you know what? Akash also has something to share, but I don't know. He's not here. Maybe he sent an email saying he won't be here today. I don't know. But anyway. All right. Okay. So Raj, you can share the screen anytime you want. So, yeah, all right. So it did go to full screen. Oh, I have to switch this on, all the time. I've been looking at it and you guys have not. I need to switch to PC. There needs to be a more explicit signal saying this is being, something. Can you guys see anything? Well, it's still synchronizing with this thing. Oh, it's cool. Okay. Great. Oh, Akash, you're online today. I thought you were going to be in class. Yeah. All right. Yeah, and all of you should switch on your cameras too. Okay, Dylan, Kaden, Justin, all of you switch on your cameras so that we actually have a full screen of people that are eager and wanting to code. Yeah, and get on the link.
You can let me know when to start.
You can start anytime you want. Okay. So yeah, okay. Oh, this is the Pig Latin thing. You got it working?
Kinda, yeah.
All right. Okay. Cool. Yeah. I'd like to see it for sure.
All right. So there's like a few bugs, but I'll just put in my name.
RJ. Ajre.
Yeah.
Is that the? I don't know. I know it sounds like it, but
yeah, that's how it'd be. But if I did it again and put in my full name,
Uh-huh.
It's gonna take the R and stick it at the end.
Oh, I see.
So that's not right. It's supposed to stick the R after the or R-A-Y after the J.
It's supposed to split the two separately.
Exactly. So that's why I was trying to do a for loop where it skips the space and the.
Oh, well, the other thing you could do is make that big Latin thing, just big Latin a word that's given to it. And then you could get the input, tokenize it into 2 words, call it 2 times. And I don't know.
Okay.
Yeah, different ways of doing the same thing. But that is really cool. Thank you so much for sharing. And you will be sharing this on the Reddit too, yeah? Because you said you're going to code
I
it.
put it in the Reddit, but yeah, I can put it again too.
Great. Thank you so much, Raj. Anything else? Anybody else want to demo? Otherwise, we'll just, in fact, what we'll do is we'll actually go, before Raj gives up the screen, we'll do that, a small demo inside of online GDB that demonstrates that ampersand thing. It's not really relevant to what we're going to do today. Maybe we will, right? I'll try and work it out, work it into what we're going to do today. But if not, it's going to be useful because it is going to be important for next week when we talk about reference parameters and stuff like that for functions. Okay, so it'll be useful, and even if you don't understand that 100%, you can just remember that. Okay, all right, so if everybody's okay with this, I think Raj, you can just clean what is it, yeah, you can Command A and delete it. Oh, you get the share URL first. Oh, did you get the URL?
Oh yeah, I'll just put that in.
Yeah, okay,
I'll put that in. I'll just open it.
okay. I just can delete all of this. So no, actually you can leave the main. Yeah, you can keep the main there, and get rid of the cout and all. No, in the new code, in the new one. Yeah, here, just get rid of the cout. You can leave the remote, return 0 there. So here's what we want to do. Say, here's an experiment, okay? And then we'll talk about the experiment. And you guys can all chime in and say, hey, this is what's probably going on. Okay, so say int ampersand NR. We should call it NR. Call it numref, num underscore ref. Yeah, all right. Yeah, that's fine, right? Okay, the previous line, the previous line, say int num, okay, int num, all right, semicolon. All right, so in numref, ampersand numref. Now, before the semicolon, say equals num. Okay, all right. Now, after that, blank lines, a couple of blank lines, and then you say num equals, I don't know, give it some random number 5, a number of your choice, yeah? And then print the contents of, print numref on the next line, okay? Print cout. Now, is Brandy here? Yeah, all right, okay. Because I think, Brandy, you made an observation on this post too, yeah? Yeah, I remember seeing that. Okay, good. All right, so now we'll put an endl after that. Now, when you print this out, you'll see that you assigned only to num. Yeah, you didn't assign a value to numref. Yes or no? But when you print it out, it's going to, what value is it going to print? It'll actually print the value of num, because this thing that we've done here is this funny notation. In fact, it is not even this notation, this ampersand notation, for this is called a reference variable. Okay, a reference variable is just like a shortcut in Mac, right? A shortcut in Windows, alias or something like that. It just means it's just a rows by another name. So if you assign to num, you're actually assigning to the other guy too. So you got two guys with two variables that actually are the same thing. That is called an alias. It's a strict alias. Okay, that is different from just having a regular variable, which will do an assignment. Yeah. Now, so the reason I wanted to pick this up is because there was something in what Randy said. Okay. So I think Randy said if you move the assignment to after the initialization or something like that. Okay. And I said, yeah, well, that's we need to demo that. Okay. All right. I think the way you had it before. Yeah, you didn't have the ampersand. So you said int numref equals num. And then yeah, okay, all right. So this is the way you had it before, yeah? So if you run it now, I think you'll get garbage, okay? Because num hasn't been initialized to anything in particular, yeah? Well, it turns out it's being initialized to 0, but I don't think you can expect that for free in all C. I don't know. You got to check the standard for C++ and tell you whether, and it'll tell you whether if you ask for an integer, it gives you an integer that's completely initialized to all zeros, or just give you 4 bytes for storing an integer. Now, Giving you 4 bytes without clearing it is the C++ way. Okay, if I was a C++ engineer, that's what I would do. Because who knows? That clearing, setting it to zeros might be a waste. Yes, so we want to extract every single machine cycle that could potentially go waste. So if that needs to be set to 0, then the engineer needs to set it to 0. That is the power of C++. You don't get pre-initialized variables, right? So in this case, you're getting a 0. I think there's a very high likelihood that your memory on this computer already was 0. You just booted it up or something like that, and you got a ton of memory, so it just got one of those bytes. But technically, it could be something else. Okay. Now, what happens if you said, it's num equals 5 wasn't reflected, even though you said num ref was equal to num. And the reason for that is because num was declared up there, right? And before it got a value, you got. Now, Brandy suggested, Brandy, you got to correct me if I'm wrong, okay? My recollection of her post was that move that assignment to after that num equals 5. Yeah? So she said move the 16 to line 20. Is that right? Yes, okay. Hey, Brandy, you should just speak up, okay? Because, by chance I saw that you said yes, okay? Yeah, I think that's what you said. Yeah, I think, yeah.
Yes, that's what I said.
Yeah, so that'll work. Yeah, that'll work because now your num is being assigned and then it's being assigned. Now, the thing is, I don't know if this level of detail is necessary to know for CS2A, but the way the compiler optimizes these things depends on where do you do the, because technically, I think you had name square bracket 0 assigned to the first character or something like that. Yeah, technically you could just use name square bracket 0 in your if condition too. It's exactly the same access time, and in fact, it's faster too. Now, even if you didn't do that, and first letter is actually more readable technically. Yes, if you look at it, even right. So if you did that, compilers are intelligent enough. Okay, these days, this is a thing that this is like 20 years ago when I implemented my first compiler as a student. I built this rule in. This is an optimization that's very old, right? So everybody does that. So compilers are intelligent enough to detect these useless variables and do that. However, if you did this the other way, then the compiler would have to wait until the closing brace to make the decision. Now, whether that matters or not, because the reason is because that thing hasn't gone out of scope. So that num that was assigned is, let's not go into the detail of that, but there are all these nuances. But essentially, what the problem that Raj was running into was that it was not a reference, and the ampersand is called a reference to a variable. It just creates an alias of an existing variable. It's going to be super duper important in next class onwards, because just having a very assignment to the reference, not a big deal. But once you start passing them around to functions, okay, that is hugely important. Yeah, because when you pass a reference to a function, that little guy out there can make a change to this big ass data structure. You've got the whole thing here, you're just passing a reference to it. Yeah, so you can make huge savings in compute time, copy time, and things like that by leveraging the power of referencing, right? Things like this come for free in many languages like Java. And hey, Brian, you're gonna fall off, okay? All right, okay. You can drink some water if you want, okay? Yeah, right. So you can turn around, maybe that would be more stable too. Right. So as I saying, yeah, it's going to be hugely important when you pass these objects by reference, because it'll save you a lot of time in copying. Yeah, in other languages, you get these for free, because in Java, for example, you got a big object and you just pass it by, you cannot pass it concretely. Think about it. If there are Java programmers here, maybe they should correct me. You actually have to put in extra work in order to pass the whole thing, because it'll only pass a pointer. You can't pass the whole thing, in a deep way. And, or you can't take a copy for free when you send it over. So data structures will have to be, passed by pointer. And I think, it's the same holds in other languages. And so this is one of the unique features of C++, okay, that you will find yourself exploiting a lot, because you don't get this for free in other languages. So you guys go in there, pass by reference is really powerful, because you can, either make it change my object or not. And we'll discover next week that even when you pass an object by reference, you can tag it in C++ and say, I'm going to give you the original, but I'm also going to mark it as const. Okay, that means I'm going to give you an original, but you can touch it. Okay, you can see it, but you can't make any changes. So you can say that, you can specify that level of detail. You'll be doing that. Okay, or you can say, here's the original, do whatever you want. It's no const. That's possible too. So all of these things you can, really hugely powerful. Okay, so how about, does it answer your question, Raj? Is everybody, that ampersand thing is just an alias, okay? It's called an alias. You don't, we don't have to use it now, but we'll start using, when you pass parameters like that, it takes on a slightly different meaning. You're passing a reference to an object. Okay, that means you're passing the alias of the actual object itself. You're not passing a copy of the object. Now in C++, there are two things. Again, all of this we'll talk about next week. Okay, next week is week 5, and we'll talk a lot more about functions, about stacks and heaps. Right? Someone asked a question about stack and heap, right? And what the difference is, and where these come into play when we talk about functions. And they're all like super duper important and interesting topics. We'll talk about them. And that's when this will also become relevant. Okay, so this is a sneak peek into what we're going to do now, next week. Okay, so if everybody's okay with this, how about thank you, Raj. Okay, thank you. How about someone else who hasn't taken the screen before? Yeah, maybe I'll. Hey, Zach was on. Yeah, Ben, Zach, Isidore, Raj. Helen, you want to? That's fine. Yeah, Helen, did you? Yeah, no, this week or next week? I don't know. Up to you. Brian, maybe Brian, maybe a good idea. Okay, because hey, you know what? There's more people here. It's not showing me all the people. And why is my window all like small like this? Now I got more people here, and it's automatically shrunk like that. Okay, and I should. Yeah. Okay. All right. Anyone who wants to take the screen? How about? Someone who hasn't, taken the screen before, Roger, Jonah, you haven't actually taken the screen before. Actually, why don't you do it? You got a Linux PC or something like that? Yeah, okay. Unless everybody's, if someone wants, we'll do it in Mac or Windows, that's fine. I know because, we'll also get to do the Linux part of it more easily. All right, so if everybody's okay with it, we'll just go because we're going to create this program. You got G++ and all, yeah? Yeah. I'll walk you through every single step, okay? Including the compilation and everything. He's going to share a screen. I'll walk you through everything. If anything is unsure, you just got to ask me, okay? And one of us will tell you what's going on. It's all going to be super simple. Now, the first thing we want to do is really, let's just grab, why don't we do it in online GDB first, and then we'll copy it over into a Linux PC. Yeah, we'll just go to online GDB. Everybody can, well, you don't have to go to online GDB. You can just see what Jonah's doing. Yeah, maybe you can also try and mirror what he's doing on your. No, let's just do it in online GDB for now. And then we'll just copy it into your VS Code. Yeah, is that okay? Yeah. Okay, because everybody will be able to, do the same thing really quickly. Share your screen. And then click on that online GDB link that what did we do there? We got us on it. Not this one, that on Reddit there's a link that we shared. Yeah. Someone could post a link. Someone could post a link in the chat, the one that we shared on Reddit. Yeah. On Reddit, on our Reddit, on the CS2A Reddit, you can actually look at for a post. Someone said, who coded last class? Ben. Yeah, Ben posted this. I think it was called the Sonnet Menjog game. Menjog. Yeah, and he posted it. So you just need to pick that up and share it here. You either fork it or you can just copy it and paste it here, and we'll go from there. Yeah. Did you get it? Yeah. All right. Oh, okay, so this is, and you can fork it. You can fork it so we can edit it. I think I can read this. Yeah. Yeah, I can read. Okay. So here, so we have the sonnet, and thank you so much, Jonah. Yeah. And then dismiss the blue part and the bottom also, so we have more of the code to ourselves. Select C++. Let's just go to C++ 11, just to make sure that we're as backward as possible. Not as backward as possible. Yeah, okay, choose anything, it doesn't matter. Yeah, just say C++. Yeah. All right, okay. So this thing, vector of strings. We talked about arrays before. An array in C++ or any language for that matter is a really powerful data structure because of this really, really super duper important property. Okay, well, two important properties like the Monty Python, right? So the first property is that all of its elements are contiguous, one after another. Yeah. Now you tell me what we can do with these two properties. Okay, it's really, really cool. Okay, right? And it's like the Pythagorean theorem or something like that. Okay, and I'm just going to tell you these two properties, and you tell me what the advantage is if you had these two properties. Okay, first is all of the elements are contiguous, one after another, starting from 0, 1, 2, 3, on all of them, right? So, and the second most important property is that all of the elements are exactly the same size. I don't know whether it's 13 bytes or 2 bytes or 15 bytes, right? Or even a gazillion bytes. Every element is exactly the same size. Okay, so what can you do? If someone tells you here is a box, all right, and here's a thing, right, and these are all the cells in it and exactly the same size, yeah, what can you do? What is it that what power does it give you? What special power does it give you? Yes, Brian. No. Let's say you cannot. Well, let's say you can loop through it, but that's not the special power we're going for. Yeah, okay. But no, we've got an even better special power. Okay, even better than looping. Okay, looping is a cool power because you can loop through it. Yeah. Okay, even better than that. We're going for something even better. I think it's even better. Okay, maybe it's not even better, but I think it's because I think if not for that, we won't be able to loop through it. I think. Right? Yes. If the other cool thing that we can get from these two properties is not available to us, looping is useless. Okay, it's only because arrays give us this incredible thing. Because of these two properties, arrays are so useful. We can loop through these arrays. Okay, so take a guess. Anyone? You don't have. I don't want to put you on the spot. Okay, if you want like 2 minutes to think about it, I can just walk around. Okay, I can take a break. You didn't think about it because it's useful. It's useful. So what does it give you? What does it give you? That's what we want to think, because that's what computer scientists do. This is the core of computer science, because you're saying, well, suppose I wanted to get to room number, some high number. Okay. Usually if it's like a linked chain or something like that, I have to start here and then walk 1, 2, 3, 4, 5. Yeah. Up to n, loop through it until I get to there. Usually. However, I can leverage this fact. Okay. That I know the distance from here to here, and I know the distance from here to here, so I can calculate the hypotenuse. Right, that's the Pythagorean theorem. But essentially what we're doing is that because I know exactly how big each element is, and I know how many elements to skip, I know exactly how many elements to skip without having to skip each one individually. So instead of going to an element iteratively in a loop, I can go directly to that element in exactly the same speed. Well, the hypotenuse is technically longer than one of these, going like that, but I think that's the fastest, right? So from a point, you go to an array element, any array element, exactly the same time, whether it's the first element or the trillionth element. Now that is the Marvel superpower of arrays. Okay, I don't think it is like super duper powerful, because you can do so many things just with this. Now, in fact, if I just stopped teaching you C++ today, right, and all your you get for your money that you paid for CS2A is looping, branching statements, and arrays, you can do a hell of a lot just with that. Okay, if just, because there are lots of problems you can solve just with these things, and you can build on top of that too. So, but we're not going to stop there. We're going to do, what we're going to do essentially is, this is just a sample of how we're starting. Is this being recorded? Yeah. Oh my gosh, it is. Okay, right. So it's just a sample. Okay, we have a lot of interesting things just like this. We're just going to say, well, you know what? Here's a list, which is different from an array. We're going to do it towards the end of 2A. Okay, this is the second. The array is the simplest data structure. Okay, the list is the next simplest, I think. This stack even, I think, is more than a list, because this is something that are intuitive, but a list is the next simple. In our request, it's the other way around. Yeah, mainly because it's easier to implement a stack. That's why I put that at 8 and lists at 9. But really, lists are simpler conceptually. So when you encounter lists, that's also a linear data structure. By the time you encounter lists, you'll understand what I mean by a linear data structure versus an exponential data structure, and how fan out happens and all of those things. But a list is a linear data structure, but it has special powers. But at the same time, it lacks some of the powers that arrays have. But the list has its own. It's like playing chess, right? A knight can move a certain way, a bishop can move a certain way. They can move like to each other. But by having both of them in your army, you can work wonders. Yeah. All right, so that's what we're going for. Of course, there are structures like a queen, okay, but they come with heavy baggage. Even in C++, you have data structures that can do a whole lot of things, but you also have to pay for those extra things in terms of extra baggage, or downloading things or modules, or even configuring the parameters of the algorithm. All cognitive load, right? So I'm just talking about the simple data structures that we have. Each one does something really, really well and really, really powerfully. And as long as you get one of these in your, or two bishops and two knights and all of these lined up, you're actually good to go. But the thing is, you need to practice a lot. You need to practice an absolute lot in order to know all the different ways in which a knight can be encountered on a chessboard. You say, well, you know what, if I do this, 3 steps down the line, I can do a fork. I have no idea if that's possible, but a chess master probably can see right through that. It's just repeated practice, repeated practice. In fact, one of my friends, she's a dancer. And some time ago, she came to visit me and she showed me a move. And it was like around 10 seconds long or something like that, okay? She starts here, ends up there, and it was really smooth and slick. And I thought, wow, that must have taken you a long time to practice, right? And in my mind, I was thinking like a long time was a few days. And she said it took her 2 months of practice. This is 15 seconds move, right? 2 months of practice and practicing every single day to just get that right. And I was thinking, well, you know what, okay, well, that is really what we're going for. In many of these things, in C++, 2A, 2B, and 2C, you're going to be solving problems, and maybe it'll take you, a lot of practice in the blue territory in order to feel comfortable enough in green to just go ahead and solve them all, bam, 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 like that. If you don't have the practice, you'll still solve them, but it'll take you a longer time, and it'll take you more back and forth with the interviewer, or or asking questions. Whereas if you've done a lot of these things already, and look at all the failure points, that is really what distinguishes an expert, in my opinion, right? So they've done it so many times, either in their mind or really, right? They know all the pain points and the failure points. So most of the time, they're just able to look at an issue and diagnose it mentally, because they simulate the hell out of it and say, well, you know what, that's not going to work, or it's going to be subpar. I'm going to change the, and maybe I'm going to change the organization and fire off all the low performance. That's organizational engineering. So all of these things just come naturally to you when when your mind is tweaked for efficiency, and that comes naturally to computer programmers, and comes naturally only because of practice, in my opinion. Okay, maybe people differ on this, but I believe that if you just keep at it long enough, you will discover all of the places where you can fail in a data structure. And then that basically seals the data structure in your mind for good. Okay, but for that you got to keep. So that's why I actually like the question that Raj. These questions that you're experimenting in the Reddit. Hey, I tried to program, it didn't work, right? And Vivian tried to program. All of those. Maybe they're the same thing. Maybe they're solving the exact same problem that hundreds and thousands of people have solved before in the world. Doesn't mean you don't have to solve it. It's just everybody does practice, exactly the same practice. So we got to keep on practicing, and you got to take all these opportunities. The code that Raj wrote, try and do a tweak to it and post your own version. And I was really, really surprised that very few people took up the challenge to do the make a name. Okay, so at least with Sonnet, I'm hoping that more of you will take this, hack it, and post your own version. Okay, so all of this counts for credit too. And it's it's really boring on a dull Reddit, okay? Because when I see posts that are interesting and engaging in 2B and or the kinds of things that Raj is talking about, or sparking in fellow students, I'm actually excited when I read these things, because I like reading these things. So it's kind of pushing you also to engage more like that. Okay, so and experimenting is all give you opportunities to experiment. Okay, you don't get opportunities to experiment, right? If we get opportunity to experiment, we should exploit it. And most of the time we don't, right? So here I'm forcing you to experiment. So you got to do this. Try variations, okay? And it's not enough to say, all right, I got it working. The assignment will work. I got my plus points. I'm moving on. No. Well, okay, you can move on. That means you're just going to get a CS2A. I got a passing familiarity with CS2A, okay? Or how C++ works. Now, if you want to be in software, be a software engineer, you got to think like a machine. And if you want to think like a machine, you got to simulate being a machine in your head, okay, enough times so that you really appreciate what the hell the machine does. Most of the people don't even appreciate what other people do, and then complain about it, right? So in order to be in their shoes, as it were, so you got to simulate the machine many times and say, well, that is why this program is failing all the time. I'm telling it to do the wrong thing, right? So I can't be mad at the computer. I can't swear at the keyboard just because it's not doing the right thing, because I'm telling it to do the wrong thing myself. But with repeated exposure, we find out and say, well, I'm not going to tell it to do the wrong thing. I'll tell it to do the right thing. So, the only person I can actually be mad at is myself. Okay. Then you say, well, I don't want to be mad at myself, so I better do the right thing from now on. Okay. So I think that is kind of how these things work. Maybe, I don't know. Okay. So here's what we're going to do. Actually, this program is almost complete, really, right? So random sonnet line. So here, I think, Juliana, you wrote this, right? You wrote this. Yeah, I was there. Okay, so why don't we write this, okay? So we're going to write a function technically we don't need a function because, right, go to the line above, Raj, no, who's sharing the screen right now? Jonah, all right, go to the line above that. Yeah, on line 32. Yeah, hit enter. All right, now you can actually say this, string random sonnet line, but for practice, we're going to do it differently, 2 ways, and you're going to do it both ways, okay? Both of you, all of you are going to do it both ways, okay? Right, so equals, okay? Then you can say sonnet square bracket, okay? Rand open close, percent, okay? I think it's sonnet dot size, okay? Sonnet dot, does it autocomplete for you? No, I don't think dot length will work. Size is a vector, isn't it? Yeah, it's a vector. This is so vectors containers in C++, they have dot size. Okay, string has dot length. I think string also has dot size. Yeah. So maybe that was introduced in C20 or something like C++20. Okay. So but in JavaScript it's length, isn't it? In other languages it's length. So they have this for some kind of crazy compatibility. Hey, Raj, you got a question?
What's the purpose of this line?
Which one? Line 33? Okay, all right. So here's what it's going to do. It's going to index into the vector called sonnets. Okay, there's a vector called sonnets. And remember the two properties that I talked to you before, right? About. So the vector is made up of elements and they're all equal size. And we're going to say, right, so inside the vector, I want to go to a certain index, but I don't want to go to the first one and then skip to the next one in a loop until I get there. That's linear in time. Yeah, so I know the index, I want to go directly there. So, but what is this index? I want a random index. Yeah. Now we can do two things like Raj did. We can say first letter equals or something like that, right? But we can say a random index equals rand percent vector dot size. No, not vector dot size, sonnet dot size. Yeah. So what does rand percent sonnet dot size do? It rand returns a random number that is big ass. It could be like 32,000. Yeah. But we don't have 32,000 lines in our sonnet. We only have like 10 lines. So we need a number between 0 and 10. So what do? We divide 32,000 by 10 and take the remainder. Well, not 32,000, whatever number that is, by 10 and take the remainder. And the remainder is guaranteed to be less than 10. Yes? So that's what we're doing there. So we know the maximum legal index in this vector, the sonnet dot size. Okay. So we're okay with any number under that. So we're saying, give me a random number, percent by that, and give me the remainder. And then we're telling the vector square brackets. By the way, we're using square brackets like in Python and other languages, even in Python, right? Behind the scenes, square bracket is actually a function call. Okay. So it says, there is a function called square bracket. We look at it as an operator, but technically there is a function called square bracket that takes the vector as this parameter, right? So here is a parameter for this thing, and the index is a second parameter. So it needs to go in. So it is writing functions internally. And in fact, in CS2C, you will write a quest in which you will have to change the behavior of the square brackets. I don't know, maybe in hash or something like that. You have to change the behavior so that you would be calculating your own indexes like that. Okay. So here's what's going on. So it's taking that random number and going into the vector directly to that index, grabbing that string and returning it to you. And that is being assigned to random sonnet line. Yes? Is everybody okay with this so far? Everybody okay? Yeah? All of you here? Good. Vivian, you're turning the other way, so I can't tell. I assume you're good. Yeah? Okay. Hey, Caesar. So far? Good. Yeah? All right, great. Okay. So now on the next line, one more blank line, and put a comment there. We're going to do and say we're going to do exactly the same thing in a function just for practice. Okay, put a comment there because it'll also remind people saying there's many ways to do this. We've done 2 ways here. Do other ways. Maybe do a function call. Come up with creative ways to pick random lines from an array. Yeah. So do that. Try all of them. Okay. You may think that I've got a way and I can see in my mind it works, but that's what many programmers do a lot of time. Okay, they come up with something and say, well, it works in my mind, so let me try something else. Okay, but many times, unless you're like cocksure that it's going to work, it's actually worth trying it out. Okay, but many times we notice that I got it in my mind, I'm going to try it out, it doesn't work, and you discover something. about it and why it doesn't work. Yeah. So it's actually worth trying it out many times, because especially since, this 10 seconds, 15 seconds to try it out. So you have to try it. Okay. So here's what we're going to try the same thing in a function. All right. So now get rid of the blank line. So string random, and then you can comment out the previous line, because now we're going to do the function. Okay. We're not going to do it. No, not the line 33. Yeah. We're going to call a function, and that's going to return the string. Yeah. Yeah. Okay. So now we're going to create that function, get random sonnet, right? When I was, when Juliana was doing that, I suggested, let's just turn the name of this function for get a random sonnet line to get random element, okay? So in fact, we're going to make this function more general purpose, right? Not specifically tailored to the sonnet grain game. We're going to make a more generic function that says, get me a random element from the vector. It's going to be used in many places, not just in a sonnet game. Yeah. So we're just going to write a function called, here's a vector, give me a random element from the vector. And that will just use it here. We'll get a random sonnet line. Yes or no? So he's generalizing a little bit. Okay. So that's what we're going to do. So let's change that function call, name of the function. Oh yeah, call it. Okay. String. Yeah, no, where you had it. Yeah. String. And then what was it? Yeah, get random element. Thank you. All right. Now here, and now what you can do is string, yeah, less than, and then no, sorry. Oh no, vector string, vector, and then string is angle. Yeah. String is within angle brackets. Yeah, right. And then say vec. We'll just say vec. Yeah, a comma. No, comma. Oh, that's all, right? We don't need anything more. That's it. Yeah. Right. So here you're just going to return that value. So you're going to return, copy that thing, copy that line 30. Yeah. It's easier to type in. Oh, and then you got to say return vec off, vec square bracket. No, returns vec square bracket. No, after the return, you say vec. No, after the return, after the word return, yeah, you say vec square bracket, and then at the end also. Is everybody okay with how this function works? Okay, exactly the same as the other one, except we moved it into a function. That's all. Yeah, no difference. Is everybody 100% comfortable with this and that? Both of those. Yeah, two ways of doing it. Everybody okay? Because otherwise, we don't want to move on. We got time to talk about these things. Everybody okay? No, Julian is yawning and all. So we'll get there. Okay, we'll get to the more interesting part very soon. Is everybody okay? Good. All right. Okay. Now let's do something. Okay. Before we implement the rest of the game, we got a random line. We'll just print it out. We'll run it a few times and make sure that we're getting a random line. Yeah. Okay. So after, yeah. Yeah, endl, endl will make sure it flushes and all. Yes. And then comment out the show line at, because it's not defined, it'll complain. Now if you run it, we should get a random line. All right, it'll run it one more time. We should get a different one because it's being seeded differently. Yes. If you didn't seed it, you'll get the same line every single time. So these are things you should experiment with. Okay. Because, I think Raj or Akash posted something about the SRANT thing before. Experiment with it. You'll get more of an insight into how SRANT works. So you comment it out and then run it many times. And you say you're getting the exact same sonnet line every single time.
You just make the program spit it out 10 times.
Yeah, make a loop, and then it'll do it 10 times. Yeah, but you won't get the exact sequence, right? It'll all be random. You get repetitions too. Is that what you're saying? You want the exact sequence?
I want 10 random strings.
10 random, yeah, but they'll have repetitions. It's it's like pick with replacement, pick with replacement.
Right.
Yeah, that's what you'll do. Yeah. Does everybody understand what he asked? So he's going to write a loop, and in the loop, he's going to call that function 10 times or whatever number of times he decides. And then each time he gets a random line and he'll print it out. So yeah, there you go. Did you get 10 of those? You only got 4. No. Increase the size. I'm pretty sure it's all there. No, increase the size of the black console. The console. Yeah. Yeah, I think that's 10. Yeah. I'm pretty sure there'll be repetitions there. Yeah, see the report, the two things. Yeah, it's a funny thing. Shakespeare, was it Shakespeare? I don't know who wrote this. In their time, they rhymed sort with report. Okay, but today I don't think we rhyme the two together, right? Running yeah. So yeah, sort and report, right? Oh, there's one more thing I noticed too. Here, respect and effect. No, that's okay. That's no, I think that I saw one more. One and alone. Yeah. One and alone. That's also near rhymes. Yeah, because they don't strictly rhyme, but they kind of yeah, interesting. Anyway, okay. All right. So we get that part works. Yes. Now can we move on to the next one? Okay. The next one is like super duper simple. Now say at. Where is that thing that called say at? Right. Where's yeah, you can get rid of the loop and all. We'll just do the rest of the code now. You can get rid of the loop. Yeah. Delete. Yeah, okay. Right. So and then you can get rid of the see out random sonnet line also, and then uncomment the show line at. Yeah. And yeah, there you go. All right. So now we're going to implement that function there. Okay, that function there. So we just go and someone has to look up from a previous class. What was that escape sequence? Escape. Okay. All right. So you need to send the escape sequence followed by this string that's given to you. No, someone else can tell you. Chris, what was the escape sequence? Escape
For what?
for positioning the cursor.
Oh, so
Yeah. So one of you should look it up. And I think it is,
it's bracket,
yeah, escape square bracket.
then the comma, row H.
Yes,
row H,
that's, yeah.
semicolon.
Yeah, did you get it? All right, so yeah, I'll dictate it to you. Right, so yeah, but start the function. Yeah, it is a void, I think. And show line at. Right, and then what was it? Column and row or row and column? Got to get the order right. Yeah, size T. Make them all size T. All right. Okay. So yeah. String S or something, whatever. str. All right. Oh, you call it show line at, so you can say line. No. Instead of string str, call it line because it's the function name is show line at. Okay. So here you're going to say C out left shift. I think it is a \027. Yeah, \027 square bracket. And then outside of the quotes, you want to push the number, column, and then row or row comma column.
That's line and then column.
Okay, so it would be line. Yeah, first line. Oh no, not line. Oh, I'm sorry. First row. Yeah. And then and then a semicolon, and then a semicolon. No. Left shift, and then within quotes you say semicolon. It's kind of funny, isn't it? It's convoluted. And then after the semicolon, you want to push column, right? We got column. Semicolon, yeah, and then uppercase H. I think that is correct. Okay, and then semicolon after that. Just put semicolon. Yeah, you close. That's the end of the statement. Yeah, and then you need to do C out left shift. See out dot flush. This is ugly, isn't it? But it's really just an idiom, and really it's a hack, isn't it? Nobody does, ANSI positioning on screens these days. So we're just doing this ugly code just to play around. Yeah, see out dot flush, open close, semicolon. I think that's it. Okay, so that will go to a certain location and print it. Now let's test it out. Let's just test it out. And if we run it, we should get a random sonnet line appear at some location, not here, but it should appear somewhere here, whatever that number is. Line. It's being given to us, yeah? Oh, we're not printing it. You got to print it. Yeah. Okay. So we need to print. Yeah, after the H, left shift line. Yeah, I'm sorry. Thank you, Jonah. Yeah, and we want to send the flush because who knows, they may not have a /n in the line. It didn't work. Oh, I see. 027. Someone has got to look into that code. No, all right, no, octal should be, oh, I see, 027 is not, it's decimal 020, decimal 27, not octal 27. Oh my gosh, the other day too, I said 027, yeah? All right, so do what Chris said. Oh, you use printf for the thing, right? Hey, all right, what is the octal value of the escape key? No, I think it's 27 decimal, but I think of the escape key. Why is escape? Oh, it's not even, all right, it's octal value of the escape key. Go, yes. 33. Okay, /033. I think that should work. Okay, that should, yes. Okay, it works. Yes. Okay. Now if you increase the console, it won't be like at the bottom. It'll be somewhere in the middle. Yeah. If you run it again, it'll yeah, okay, it's still there. Why is it coming? All right. So here's what we're going to do. All right. So now let's go back. Let's go back to our code. Okay. Let's go back to our code. And we'll also say that the top left row is just 2, second row from the top, and then the fourth column from the left. All right. So change the numbers. Stop the code. Why is it still running? I thought it should have stopped. Right. Oh, it is. Right. So yeah, change the numbers to from 25,50. Let's make that 2,4. Okay, so it's not like far away. No, it's all right. Okay. Yeah, okay. So that's there. Okay, so now go into the code. We're going to make some more changes. Yeah, we're going to make some more changes. All right. So further down. After you print the line. Okay. Now, in fact, what we'll do is actually do something nice. Okay. So we're going to get a random sound line. Okay, sure. All right. So go to line 46 and hit enter. Go to line 46 and hit enter. Now, all of this really not part of CS2A because we're just adding frills and niceties, which we don't have to for this program, but it is just a way for us to just keep coding and practicing. Okay, so we're going to do these things. Also part of, a nice program. So we're turning this program into something nice, at the same time giving us an opportunity to practice coding. Okay, so that's what we're doing here. Okay, so on this line, hit one more enter, and start a comment. And say warn the user that a new sonnet line is on its way. Okay, and you put a cout statement there, and then sleep for a couple of seconds. Okay, cout, and then yeah, cout. Yeah, but print a warning, right? Open a quote. Stand by for a random sonnet line. Okay, and then ... and then a new line. Yeah, all right. So that'll do. Right, semicolon there. And then on the next line, you're going to say sleep 2 seconds. Okay, let's not sleep too long. Right? Brian is already very sleepy. Okay, so don't want to use the word sleep. Okay. All right. You can actually go and wash your face, drink water if you want. Okay. Actually, Jeff has got some water right here too, right next to him. Okay. All right. Okay. So we've got, what are we doing here? I lost my track. Yeah, okay, sleep 2, all right? Okay, so it's gonna say standby, sleep 2, all right? Now, after that, on the second line, it is going to print, well, let's put it on the third line, okay? So there'll be a blank line before, right? But make it a third line, not the second line. Top left row is 3, all right, good. Right, now after you've shown it, you got to sleep. Now you're going to show that line, okay? So after that sleep, you're going to print the line, okay? Print the line. Yeah, sure. I see. Okay, after the sleep, you're going to show the line. Okay, good. All right, and after you show the line, print a yeah. After you show the line, print I don't know, timer. Do we have the timer function here? For now, just say we'll put the timer later in, right? But put in the timer later. For now, just say cout. Oh, you want to put a cout there? Okay, yeah, right. Yeah, you can say memorize it. You got 5 seconds to memorize it. All right, so say you got 5 seconds to memorize it. Okay, you got 5. Yeah, memorize it. All right. End new line or something like that. All right. Okay. Now you're gonna sleep for 5. Does everybody see where we're going with this? We've got a trajectory, and so you already kind of have a sense of where we're going with that. We're showing the line. Right, warning the user, showing the line, sleeping for 5 seconds, and now what are we going to do? clear the screen, okay? In fact, we have the exact thing to clear the screen. We'll just go to the same place, and instead of show a line, we'll show lots of blank spaces. Yeah, okay. So after 5 seconds of sleep, it's going to say clear the line, okay? So you're going to say show line add, okay? And then top left row, top left column, and then, boatload of blank spaces. Yeah, double quotes, and then lots of blank spaces. Now it's going to show the line. Yes, Chris?
What you can do is you can actually run another CS2A sequence that clears the whole screen.
Yes, you could technically do that, but that'll also clear, those things saying it was standby and things like that. Yeah, yeah, you're right. You're right. Yeah. In fact, we could do that. That's something that you can experiment. Yeah. So here, when you show this game to, let's say, your brother, maybe show it with this effect, right? When you show it to your sister or someone else, or your dad or mom or aunt or uncle, you can say, well, I'm going to not clear the whole screen. So you get a chance, because, if one of them is wrong, one of them will point it out. But if you got it debugged with one person, you can show the other person also the debug version. You can, when you show the other person, you could say, I'm going to make a change before I show it to the other person, because then I'll get a chance to, another person to debug it for me. So now in this class, you can get people to debug your code for you, but you can actually get lots and lots of people to debug your, the effect of your code for you, because you write things and show it to people and say, hey, it works, it doesn't work. And they'll tell you, hey, it doesn't work. So I can go back and look at the code again, right? That's exactly what happened in the questing system too, right? You write the code, and the questing system will not tell you what the hell is going wrong, but it'll basically tell you whatever you were told to do, that doesn't work, okay? That does not, it's not right. So then you got to figure it out yourself, just like in real life, okay? Many times we only know that things are not going right, but we don't know the exact reason why they're not going right. And you got to reflect very deeply and find out. And many times people won't tell us, right? And for our own good, because we got to get better and better at it. And same in programming. Right? So you should never ask, especially here in Silicon Valley. Many of you have relatives, right? Who are probably in some of the tech companies. Some of, someone in your family, right, is somehow associated, I bet, right? Very high chance with Google, Facebook, so many things here, so many things. So if you really wanted to, even if you didn't have anyone in your family, right? This is just a valley. You can go online, post something, go to a meetup here. Someone will just help you out. So if you really wanted to get help to get through any computer science class, you can get it freebie here in the Silicon Valley, okay? And unless a student actually applies themselves by themselves, saying, well, you know what? I'm actually not going to make use of all the help available to me right at home, right? I can sit on my couch and say, hey, Dad, can you come and take a look at it? No, I'm not going to do that because I want to learn it. So unless you have that initiative, you can pass a class, okay? That's a tragedy, I think, that you can actually pass many classes without actually having real mastery, okay? Well, all professors try to make it hard. Well, maybe not all. I try to make it hard anyway, right? Because it's not like I want you to work hard and have a hard time. If you're going to be, work hard and, call me a real bastard for, cracking a whip over you, that's okay. Because, you're going to forget about me in a little while. But what you get out of this, we're going to stick with you. So it doesn't matter to me really, because you're not going to come and, shoot me just because I'm going to, make you work hard, right? You're going to curse at me and you're still going to work hard, right? But that's okay with me. And the same with my kids too. Really, you can talk to them later if you want, right? So I say, I'm not going to give you the answer, but I'm going to be a bad guy, but that's okay, because at the end of the day, what really matters is, I'm going to be gone in a little while, but what you get out of this is never going to be gone until you lose your brain cells at some point in life, right? To a machine or something like that. So it's going to be part of you. And so, yeah, that is why I'm pushing you. So don't take right now, even if you drop, really doesn't matter to Foothill because, it's past census date. Yeah. On census date, we take count. And we want to say that, classes more than 20 students is worth running. Because otherwise, really think about it from Foothill's point of view, right? There could be lots and lots of professors saying, I know how to make this incredible, lamp or something like that, okay? And make it in 2 days, but they'll stretch it out over, theoretically. I say, this is an incredible lamp. I can make it for you in 12 weeks. And maybe 2 people will enroll in it. They're kids, right? But Foothill can't afford to run it. So we have a threshold, 20, okay? That's why I said before you drop class, be careful and all. But we actually have a lot of students in this class. That's really cool, okay? Including the online guests also. That's really cool too, right? No, we do get funding. it's a complex calculus. That's why I'm not in admin here, okay? Because they have to deal with, I think, a lot of issues. It's not just money going in and out. There's lots of things they have to plan into the calculus, right? So how much money goes where, how much of the money goes towards students that would learn if they were given an opportunity, but they're being denied an opportunity because just of lack of resources. Yeah, meaning that you're fully intellectually capable of learning this, and you're not learning it just because you're not able to make it to class on time, because you got to take public transit or something like that. Yeah, and those are things that Foothill actually invests money into. There are students at Foothill that could learn well, but don't, because they're hungry. Many of you are maybe unable to relate to it, right? In the Silicon Valley, but we have students who are brilliant students, but they are tormented by hunger, and they're not able to late at night in PSAC. Because sometimes when I was more on campus in the previous quarters, I used to be in my office late also, and many times I see students working on assignments out in the PSAC building, and I'm in my office and I see these students out there, they're working hard, and I'm working maybe 9 p.m., 10 p.m. sometimes, and they're still out there, and they're not, no sign of going home. But sometimes I look through the glass, and they're going to the pantry and looking there to see if there's any cookies or biscuits or stuff that the people have left. And I saw someone, look for stuff to eat one day. And the thing is, Foothill actually knows, and it has a pantry, but it's not in PSAC. Okay, so that's what I mean. Foothill recognizes that there are students that go hungry and they're not able to learn. So we make every effort. That's why our whatever that department is called, Chris, I think, Chavez, not Chris Chavez. He's the student success guy. Or they invest a lot of time and effort into making sure that if you're able to learn, we'll try and remove all possible barriers, including money, right? Because that's one of the main things, right? If you say I want to learn, Foothill will pay a fees for you. If you really, if you go and say that to someone there, right? So as some of you probably, you can go and try it out. So we will actually try. Now, I'm not rooting for Foothill, right? I'm retiring in a couple of years, but I'm just pleased for what I see. That's what I mean, right? So you should be, but at the same time, all of these accommodations, right? In my class too, when people say, I got sick, I got this, I got, someone in my extended family died, I had to fly to overseas. That's okay, right? But does not mean that in my class, okay, and all online students too, you get every slack in extensions and things like that, but does not mean that you will get a free grade out of it, right? That is the only thing that I don't say that just because you are going through challenges mean that you can get an easier grade. You got to work as hard, but we'll try and make sure that as much help is provided to you to compensate for those challenges as possible, right? So if right, so that is basically what I'm doing. So I'll give you extensions, work with you, right? Set you up with tutors and things like that, but it does not mean that I'm going to expect less from you just because you're challenged, right? Everybody in life has challenges, okay? People, people always feel special about themselves for the challenges they overcome, but many times everybody has challenges they've faced, and they're unique challenges. And so everybody's really special if you come to think about it. From looking at everybody from their own perspective, this is special, and they've gone through these challenges. That's what defined them. And so everybody's having a hard time learning and finding time for these things. And so we will make every effort. I personally will make every effort, right, to work with you to make sure that if you have challenges that I can address, right, if sometimes you have a challenge that I can't address, right, and it involves confidential matters, obviously, I'm totally not. So this Foothill counseling, and I do refer students to Foothill because there are counselors here, free counselors trained to sit with students and resolve their problems, right? Confidential things like that. So we have all of these things that I refer you to, but the only thing that I never cut is slack. Okay, so well, slack meaning I can give you extensions, but not a better grade. And a lot of students hope you won't hate me for that, but probably you won't. But students have said bad things in the past, but obviously you're not affected by that because you have enrolled in my class because of that. Because people say you have to work really hard and not get a good grade, but it's not because I have spite towards you. I know that you're able to do it. Okay, so just because you belong to a certain demographic or because you have certain challenges, I don't assume that, well, you know what, that person is not capable of doing this, I'll give them an easy A. No, I believe that everybody is capable of doing kick-ass stuff. Okay, so I'm going to push every single person, no matter who you are, to be your best self. Okay, and if you're not, I will actually push you. That's basically that's all I can do, really. Okay, so all right, here's what we're going to do. So we're going to erase the line. All spaces. All right, now you can print a prompt saying, guess the line. That's all. I don't want to do the last two lines. You guys are going to do the last two lines and demo it. Okay, well, you run it once, and then you can take your own time and turns to modify it and demo it. We have time for the demos. What time is it now? Oh, it's 7. Right. We got almost an hour. So what we'll do is guess the line. Within parentheses after after, say you got to get it exactly right. Okay, you got to get it exactly right, including punctuations. Okay, so I think otherwise people will basically take the easy route and just say, these are the words. Okay, so you got it exactly right. Besides, if you said I'm going to go for approximate matches, your job as a programmer is harder, because approximate matching is harder than exact matching. Yes, the exact matching, you can say string 1 equals string 2, bam, like that. Yes, one statement. If you want to do approximate matching, you got to do edit distance and find out which character changed and things like that. That's a complex problem in computer science. In fact, finding the edit distance, that's called the edit distance, right? Turning one string into another is called editing the string, right? And editing actually can be decomposed into just 3 operations: insert, delete, substitute, right? Those are the only 3 operations you need to turn any string into any other string. Yeah, editing. So if those are 3 operations, that means that any edit can be quantified by the number of operations, the minimum number of operations will take from here to there, right? Kind of like when you do research in machine learning, for example, it's called the minimum description length principle, or minimum message length, depending on which school you come from. Okay, it's saying that if you have a hypothesis and data, and that the hypothesis claims to explain, okay, which is the better hypothesis, right? Is it the Copernican system, or or something else that's heliocentric, or something, 2 different systems, 2 completely different systems, which and from here on Earth, it doesn't make any, we can't tell. The average person cannot tell which is correct. Yes, the average person can't even tell if the Earth is flat or round, really, if you think about it, unless you go to a coast or something like that. Yes, so so you can't tell many of these things. Theories. So how do you tell this theory is better than that theory? How? Right? I actually had a philosophy professor who actually majored in his own PhD back in England. He said his own theory was his own, I think. Anyway, he wrote a book about it later on. It's called verisimilitude, right? It's likeness to truth. Verisimilitude, veritas, right? Very is truth, right? Similitude is similar, right? How similar is it to truth? Verisimilitude. That's the word in English. And he did an entire PhD thesis, I believe, on value and something like that. Or anyway, his book was about this verisimilitude. He, back when I was a student like you guys.
So I don't put the package.
Or sleep, UNISTD. Yeah, so anyway, the minimum description length says, right, the theory that is most convenient for humans is the one that minimizes the total length of the theory and the data together side by side. So if it takes n bits to quantify your theory and takes m bits to quantify your data given that theory, right? You can think of probabilistically, if you have given something, that could either mean heads or tails, right? So one thing could influence another, right? So dependent events. So you code the theory, and what is the likelihood of the data given the theory? Code them both together. What's the total length? That is what defines the quality of the theory, according to one metric. Anyway, it's called the minimum description length principle. Someone called Rissanen in IBM research at some point in the 1990s, right, popularized this. It's been around for a long time, even in in information theory and data mining, and in statistics, decision trees. It's been around for a long time, but this guy, I think, was the one who was popularized this a lot. Anyway, it's very similar to what we're trying to do here. Okay, all right. Yeah, okay. So if this goes, all right. Well, what is it? I can see. Hey, where's the line? I can see the line. It never showed me the line. I may not evermore acknowledge. Hey, that's wrong. Hey, something's wrong here.
Yeah, it's not. It's not like
No, it got 2 lines. It got Do it one more time. Hang on one more time.
There was one line, but then it said memorize it in 5 seconds right afterwards.
Oh, I see. Put an endle after that. Put an endle after that. I put two endls after that, in fact, put two endls. After you see out the line, put two endls. Show line at, and then, oh, actually, when memorize it, just put two new lines before it, two slash in. No, just before memorize it, capital M, put two slash in. All right. So everybody understand what we did there? This is memorize was, coming up there. We just said move the cursor up there. And all right, so let's remember this, okay? Nor thou with public kindness honor me. Okay, I got it. Okay, capital N. All right, so all right, now we got a lot of time. Nor thou, capital N. Oh, you got to get a new line there too. Public honor. No, public kindness honor me. Did you remember that, Jonah? Did you remember that? Yeah, okay, all right. So I got it 100%, I think. No? All right, so here's the other thing we can do. So if we got it wrong, you got to tell me what the right thing was, okay? So you say, you got it wrong, but this was the original. Or you can say, in your own version, okay? Now you got the whole thing. Everybody's got the logic for the whole thing. Now you're going to play around with it, okay?
I misspelled it. But yeah, I'll add that right now.
Okay, but no, that's enough, okay? No more. Is everybody going to develop your own? Anybody have any questions? Yeah, and you can also put, you can stop sharing. And you can also do your own special effects like Panini did with the counter, instead of saying 5 seconds, you can do bam, bam, bam like that. Or, the timer that we did before, that's fine too. And knock yourself out. And then put the new lines and space things out correctly. And it's really cool now, because now you can also experiment with putting in a loop, right? So as long as you keep getting it right, it'll go on to get a new line for you. So if you're on a train, you can just play it in a loop. And then the first time you get a wrong one, that's the end of the game, right? So you got to keep going again and again. Okay, so let's do that. And when you got that, it's actually one small step to turn it into a JavaScript game too, right? That anyone can play on the web. Let me show you later on if you're interested. But this is basically it. Okay, so everybody now, I think, what time is it? 7:08. How about 10 minutes? Okay, not 10 minutes. How long do you want? 15 minutes? All right. Play it by ear. Okay, everybody now is going to work on your own version and make your own fun thing out of it. I want to see more demos this time. Okay, more demos, and in fact we'll go for the demos with the people who haven't demoed in the past first. Okay, so you should all take this as an opportunity to cut some code and do some cool stuff and then inject variations, put it in a loop so that if you play this game in a loop, like if you get it right all the time, you probably memorize the sonnet. Yeah, okay, or all the lines from the sonnet, which really is, most of the time that is the hard part. Yeah, and then it doesn't. By the way, I see. I wanted to show you that other thing, right? I wanted to show you how to turn this into a Unix command. Why don't we wait for you to play? Yeah, play with this for a little while. Yeah, you can do it on your computer. So essentially what we're trying to do, if you want to turn this into something like a typical Unix command, what do you do? All right, so you're going to give it a default sonnet that we've done already. It's already in there. It's baked in, right? However, what you're going to do is also give it the ability to take a command line parameter. If it is not called with a command line parameter, you're going to use the default sonnet, which is already baked in. Yeah, but if it is called with a command line parameter, it's simply just going to open the file, right, named in the parameter, and I'm going to read the lines into the vector. That's all. Okay, that is enough. And so that is two core variations that are necessary for a Unix command, is that it should be capable of being invoked on its own and still do sensible things, which we're doing with the default sonnet. If it's invoked with an argument, you should have the ability to change its behavior, which we're doing, saying, well, you know what, I'm bored with this old sonnet number 36. I'm going to use a new sonnet, maybe by Byron, or maybe Chinese sonnet even, right? And or a Japanese koan. Yeah, so you can put that in a text file and say sonnet mykoan.txt, and then the lines that come out of the screen are going to be from there, and then it's going to be in a loop, and 10 times you memorize the koan, right? And it'll be really fun. So that's all. And I think it's a mildly interesting. Yeah, we don't want it to be so. I don't know, maybe it can be furiously exciting too, but I think if it's furiously exciting, we miss the point sometimes. So I think this is just mildly exciting so that you can work on it and play around with it, but at the same time it has enough scope for variation, so you can try out all these different ways of doing it and And you may come across an interesting variation that we haven't even imagined, and that will make for a fantastic demo, right? And again, not just demoing in class. You got to develop this and also post it in Reddit. Okay, this time I'm going to be looking in the Reddit. Everybody, all of you, should post your own versions on the Reddit. And by the way, if you're stuck, Chris, Panini, where's Simon? He's not here. This is a whole bunch of people that you can try to steer clear of the students, right? So that's what I said to some of the other students who were trying to ask if we can go in a breakout room. Oh, Simon, you're online too. Right. So I said, I think as much as possible, if you want to go into a breakout room with a tutor or someone who's who you want to help you, try as much as possible to leave our current 2A students as the last resort. Yeah, because I'd prefer for them to be in class all the time, working with all of us. Although there are students in this class who are comfortable going into a breakout room and helping someone else. But I would prefer that all the students are in class. But because we do have a tutor, right? Chris is being paid for that. And right. So and right now you're happy to go in a breakout room and coach people too. Yeah. Yeah. And so I'm pretty sure Panini can also do that. So if you want personal help on some of these things, this is not quest code, right? Not quest code. You're just saying, I want to do this. Can you help me? And I can do that. I can also do that. But I would prefer personally not to. That's fine, Akash. Thank you. Right. I would prefer personally that you don't go into a breakout room as much as possible. Do it here, and even if you have a question, you can just ask here, and so one of the others of us will just jump in and answer. And that way, and the advantage of doing that is that if you get stuck in a problem, many students think that they're the only ones who get these problems. Okay, and as a teacher, I know, right, from having seen many students come across the same kinds of problems. Okay, and many of them think that other students don't encounter the same problems. But that is wrong, right? Statistically, it is wrong. So if you're just vocal with your problem, you'll recognize that, that's a common problem. Everybody has the same problem. People will chime in and say, hey, I had the problem too. So don't struggle in private, okay? Don't struggle. Well, what do you have to lose by struggling in public, right? I don't know. Right. So just don't have any problems. Don't think, don't give a second thought to what people think about you. All right. I think that's the bottom of it, right? So your goal is really to get to the bottom of the knowledge and and figure these things out. And if it means asking 1,000 questions, knock yourselves out. Okay, because there are people to help you. There are people to help you. And I think you should take advantage of the people to help you in a college setting, okay? Not people to help you at home. Or people working in tech companies. The reason being is that they may not have the experience of telling you or not telling you the answer. Okay, that I've said that before in 2B classes. Even as parents, the harder challenge is deciding not to help. Okay, because it's easy to help. Now, easy to help meaning giving the answer. Giving the answer is always easy. And many people take the shortcut and do it, okay? But telling you that I know the answer, but I'm not going to give it to you, that takes a lot of strength. I think maybe it's a lot of practice, or maybe just getting inured to saying, I'm going to say no, and I know that they're going to be disappointed, and I'm going to feel that disappointment, right? And I feel it so many times that I'm just inured to it, because I know that they're going to be disappointed, but they'll come around anyway. The first few times you're not sure, right? You see they're disappointed, and say, oh my gosh, maybe they're wrecked for life, right? But then you see that happen and then say, well, I thought I spoiled their life, but no, apparently I didn't, okay? And they're okay now, but they're better off, right? And then you say, all right, I get a better, more confident, saying, well, I can do this more times now, right? So you get more and meaner and meaner and meaner, as long as it doesn't kill other people. Not meaner in a mean sense, right? Saying, I'm not going to give you the answer. You're going to toil and find out yourself, even if it means you're going to bleed, but it'll be a good bad blood, okay? So, but I'll make sure you don't die. All right, I'll make sure you don't die, but you got to work it out, because once you work it out, it's only one time. A lot of people, right, don't believe it when I say it's only one time. And I think, and it's fair, because there's no evidence that says it's only one time. In fact, it's a very good correlation, because when a dancer friend of mine told me that this dance sequence was 10 seconds long, and it took her 2 months to practice, or something like that, some crazy number of hours. The computer scientist, or maybe not the computer scientist, immediately then my first thought was that, okay, well, this is actually 10 seconds, but it's part of a, a 4-minute piece or a 5-minute piece. So that means, like, there's 40 of those, and it's 2 months times, 40 times 20, that many months of practice. Okay, that is, I think, the naive way of looking at it. And that was the first thought that jumped into my mind at that time, because I was not in that field and not able to feel. But as computer scientists, one of the things that I think that you will also find is that if it takes n hours for the first problem to be solved, it does not take n hours for the next problem to be solved. It takes considerably less than n hours. But students don't have any idea, right? And they will continue to believe that is m times n, despite a lot of evidence, right? Or people telling them. And so you've got to knock yourself out of that and say, I'm going to put in the hard work for this, even though it's not like, that is not going to be replicated 50 times. Only the first time is that hard. The second time is half as hard. Okay, so in fact, if you sum it all up mathematically, it'll be a convergence series. It'll be a finite number. But if you look at it, you may think, well, even in the best case, it may be a harmonic series. A harmonic series is not convergent. The harmonic series convergent? No. All right. So, right. So it look like it's converged, but it's not converging. I've been at it for 15 years, like PhDs, right? So I'm one of these people that started PhDs with me. They were still doing their PhDs when I was working. And so it could be like that. And of course, not that my PhD was any good, right? I just got to I got through with it, squeaked through. Yeah. So yeah, it's not going to be that hard, but people always think that it's hard. People always think the younger you are, I think, right? It's a hypothesis. Maybe when you're older, you can figure it out and, do a research project and publish it. I think the younger you are, maybe, I don't know, maybe you feel, maybe I'm wrong, okay? Maybe you just feel that things are much harder than they are, okay? With more experience, I think you generally tend to figure out ways of making things easier. But these things just don't come, without experience. You got to, be in that situation and say, well, you know what, that is actually a pretty cool way to solve it, but I can use the exact same strategy in 15 other places, right? So that kind of thing, it's just practice, okay? I'm sorry, I didn't mean to take up so much of your time, right? Thank you, Chris, for closing your laptop lid, okay? That kind of reminded me, all right? All right. All right, okay. All right, okay. All right, so I'm just going to walk around, okay? So I'm going to leave the screen now. Hey, Simon, you're okay. You're good. Okay, good. All right, okay. So why don't you guys go ahead and knock yourselves out with the code. In about 10 or 15 minutes, when you're ready, you can start demoing. In fact, the first person to get ready can start demoing already. Other people can still continue to. And in fact, when someone's demoing, maybe you get new ideas too, to change your code, okay? And remember, we're all there to pull into breakout rooms, but just ask for your questions. Was that useful, what we covered so far? Okay, so the main thing was getting familiar with vectors. Later on, after you're familiar with vectors, maybe on Thursday, towards the end of Thursday, I'll introduce the raw version of vectors, okay? That is part of CS2A. You need to know, especially if you're C++ programmers, you need to know what a native array is, okay? A native array is just a block of bytes, bam, like that, okay? You can tell the compiler, I want 50 integers, and it will give you 50 times 4, 200 bytes, 200 contiguous bytes in memory, bam, it will give it to you like that. And then you can say, well, that is the address, the address of the first integer is OX, hexadecimal 45. The next integer is hexadecimal 49. Well, it's not 45, it's got to be even numbers and lined and all, right? 46, 50, 54. So you know exactly. So if you want the fifth number, you can actually go to 4 times 4, 16 plus 40, that's 56. So you can go directly to that memory location and you get so that's your array. And but it is painful to use, okay? Someone asked a question about stacks and heaps, and we'll cover this next class. Really, it's only next week, but we'll cover this, just touch upon it next class. Stacks and heaps. You can only get a certain amount of space on your stack. It's always good to work with your stack as much as possible. Now, stack is easy access memory. It's really there, and you don't have to manage it explicitly like the heap. The heap is terabytes of memory. If your machine has like terabytes of memory, all of that is available to a C++ program, but it's not in your stack. It's part of what is called the general heap, right? It's a heap. It's out there. Anybody can ask, right? That is a heap. And so big that when you ask for it, right, the system will give it to you if it's available, but you got to give it back. So that means you got to remember, okay? So heap involves active management of the memory, which other languages do for you. So if you're coming to C++ from Java or Python, maybe spoiled by saying, you know, give me this object, and then let go of it, and the garbage collector will pick it up. Sloppy programming, okay? That is why I think, in my opinion, right, the better Java and C++ programmers, better Java and Python programmers are good C++ programmers to start with, okay? If you're a good C++ programmer, then when you use Java and Python, you will create and destroy object in an optimal way. Because many people underestimate, I've found, even, you know, out there in the industry, right? Many people underestimate the cost of object creation and destruction. They just say, I'm going to create one and destroy one, and you can put it in a loop, and that's going to run like 1,000,000 times, right? Because just that overhead just adds up. But lots of people are not aware. Like in Python and Java, you can say, here's an object here, it goes out of scope here. But those are things that I think you learn to look out for when you're a C++ programmer. And in Java, for example, you'll say, well, I'm not going to create an object here, but I'll, instead of the object, I'm going to use the 3 native types that go inside the object, because those are the only 3 that'll get manipulated. So I'll use the 3 native types in here. So that means it won't be part of an object that's created and destroyed, but you'll actually have native types that are on the stack, and you can manipulate them. I don't know if all that makes sense, but you will be a much better programmer, in my opinion, if you know C++, in Java, Python, any other language. And that is why getting down to the nuts and bolts of it is important, regardless of what programming language you learn later on, because this basically, you know, stands you in good faith all along. Okay, so I don't know how we got started talking about that, but someone asked a question. Yeah, sorry. Okay, all right. So yeah, go ahead and hack away. And if you have any questions, just let me know. Okay. And if this class was useful, we'll start. You know, we'll take it to the next level on Thursday. And if you have any questions, call me. Okay. I'll go and drink some water. Everybody's okay. Nobody's.
Caesar has a question.
Oh, they had a question for me.
He has his hands up.
Oh, Caesar. Yeah. Okay. You have a question? Why don't you ask on, because I'll the online question that students may also have this question. Thank you, Chris. Hey, Caesar. Yeah. What is your question? One sec. Okay. Hey, online guys, can you hear Caesar? Online guys, Simon, can you hear Caesar? Caesar, say something.
I could not hear anything.
No? Oh. Okay, Caesar, can you say something? Hello.
I
Or something?
couldn't hear anything. Yeah. Oh, now I can hear. Now I can hear.
All right, go ahead. Thanks.
So I keep on getting this error on line 11 on the vector thing. It says that I can't put it there. Like,
You want to share your screen? I can take a look at it.
Yeah.
But you know, this is, you're listening to him with a lag, and that's kind of screwing with my. How did we deal with it last time? I forgot.
so down here it says like.
I see. All right. So you got it. All right. So all right. So do you want me to help or? So what you have there is the left shift operator, but the way to declare a vector template is one angle bracket. Okay, one angle bracket, one and one. You got 2 and 2. Yeah. Everybody. Hey, maybe you need to turn off your microphone then. This is much better. Yeah. That means they can't hear you. So whenever you talk, like a walkie-talkie, whenever you talk, you can unmute it for these guys. All right. So yeah. Get rid of the spaces in front of it. Get rid of the spaces in front of it. Yeah. Back. All right. And then turn the 2 left shifts into 1. Right. 2 less than into 1. The 2, you got the 2 into 1. Right. And then this should be right. It should be like, like this angle. It's called angle brackets. It's not less than, or it's got different meaning now. Angle brackets. No, left. No, it's good to be right. The other one. It should be like this on line 5. You see that on line 5? Like that? On line 5, you see that? Like that. Yeah, everywhere. Yeah. There you go. That's the one. Yeah. Okay. And usually, yeah, that's it. Yeah, that's fine. Oh, you don't have IO stream. Oh, I see. You need to include, go to the top of hash include IO stream. Many people may be having exactly the same problem. Okay, Caesar, thank you for, bringing this up. Right, enter, and then say hash include CSTDLIB. Yeah, it's a C standard library. That is where the srand and the rand function are actually defined. Oh, it's still not working? It's still not working, Caesar? You did that? Okay, say stdlib.h. Oh no, CSTDLIB, not LB, LIB. Yeah, try run it right now. Too far. No, hang on. Oh yeah. All right. So srand. No, not srand. Rand. Okay, I didn't even read what you had there. Instead of on line 16, you have srand. It should be rand. Yeah. And also, while we're here, let's clean up the code to get the right formatting and all, so it'll look more nice. No, go where you had. No, that should be that should be srand. Yeah, I'll explain this later. Go back to where you were before. See, you see that line return vec, right? It should be indented in. It belongs to the function, so it should be inside. Yeah, tab. And you can get rid of the blank line above and below it too, so it's tighter and cleaner. Everybody should be doing exactly the same thing. Right? Yeah, and you'll get into the habit of doing this. Also, the next one also, you got blank lines above and below. Get rid of it, clean it up. All right. There you go. If you run it now, it should work. Yeah. No, still more. Semicolon. Which line is it? Line 15. Oh, you didn't have a semicolon at the end. It's good we're running into all of these, yes? Because these are things you'll run into when you're questing. When you're writing your own code, you run into these things. And it's good we're running into this now, so you can exactly the same thing you'll be doing. All right. One more. Sleep 2, semicolon. Yeah, most common. Yeah. Oh, I see. Semicolon before cout, and you got an uppercase cout. Okay, should be lowercase cout. Yeah. What is guess? Oh, you actually already started changing the program. Okay. All right. No. So you have to declare guess as a variable. So what you can do is just above the line above. Yeah. Hit enter. Yeah. There you go. Hit enter. One line up. You can say string guess. Right. You can also put this then semicolon after that. In fact, to make everything cleaner, you can just cut the line and put it on top with all of the other declarations. Cut the line, yeah, and go to the top where you have all the other declarations. There you go. Const size t. You can hit enter there. Although, you know, it's debatable whether this belongs there because you have some consts, and so you can play with the aesthetics. Okay, now if you run it. Hey, no, I want to. Oh, no. You got to put the new line. Okay, kill it. You got to put the new line. Hey, Jonah, where was it? Yeah, you got 5 seconds. Okay, so put /n before YOU, right? Yeah, put two /n's before after the cout in the front of two. You got in front of in front of the Y. Oh, you got to stop it. Yeah, and then put /n in front of the Y. /n in front of the capital Y. Yeah. In front of the capital Y. In front of the capital Y. That is no in front before. What that says is that before you print, and it's SECONDS. Okay, seconds. Yeah, SECONDS. Okay, memorize it. Okay, all right. Now what that says is /n is just new line. Go to the next line. So you're saying instead of printing the prompt right there, you're going to print the sonnet line and then new line and print. You got 5 seconds there. So if you run it now, you'll get a much nicer look. Yeah. Okay, I'm going to try and remember this. Oh no! Oh no! Kill it! Let's not print at that location. Top left and top left. Change it to 2,4. Okay, change it. Go to the top. Go where you have top that define. Yeah. Not 2550. Change it to 2 and 4. No, 4 and 4. Yeah, 4 and 4. I think much better. 4 and 4. Okay. All right, so if you run it now, I think it'll look just like what Raj had. Okay, nor thou with public kind. It was exactly the same thing that Jonah had. How come it's if you run again? Let's see if we get exactly the same thing, right? Oh, and it's gone. Oh, but I see. After you got 5 seconds to memorize it, it's gone. Now we didn't print a prompt saying what is your guess? Oh, hang on. Yeah. All right. So you got to play with the aesthetics of it because you can see it's a mess, right? But you know how things are appearing at different times, yeah? So you can print the prompt and then guess the line should, and then it should print the line immediately. It should say you got 5 seconds to memorize it on the next line. And then under that, it should say guess the line, right? And then it should erase that line. And then it should say, all right, let's see, stand by for a random sonnet line, 2 lines, all right. And then after 2 blank lines, in fact, just put one /n there. We'll try and clean it up here, okay? 1 /n, not 2. Yeah, all right. Got 5 seconds to memorize it. Okay, sleep 5. Now, and then, oh, no, yeah, I see. Not just 2 double quotes. It's got to be a double quote, lots of spaces, and then another double quote. Because you want to override it with spaces on line, yeah, on that line. No, the line above that, line above that. At the end, you got 2 double quotes. You got to be lots of spaces inside of that. Yeah, it's got to overwrite that line. No, that's not enough to overwrite the whole line. Yeah, I think that's probably enough for now. All right, now hang on. So it shows the line, and then it shows the line. Oh, and then erases it, and then right under that it shows. Oh, now /n after before the guess say /n, just one /n. Right now, right under that, it's going to say after the line has disappeared, it's going to say now guess the line. Okay, now you say don't guess the line, now guess the line, Yeah. Right. Yeah. Oh, and you don't have the check after that, right? After get line, after the next line, hit enter, and you're going to say is guess equal to random line. If yes, you're going to say hooray. If no, you're going to say alas or something like that. Yeah. So you can do that there. If guess equals, if guess double equals, no, within parentheses. Yeah. If guess double equals, double equals two equal signs. Yeah. Random sonnet line. Yeah, right? No, not semicolon. If the guess is equal to, then you want to say hooray, right? On the next line, you can say, on the next line, you can say hooray. Indent in, it's part of the if statement, indent in, say see out, hooray, you got it right, and then you can exit. Because you later on, you can put it in put the whole thing in a loop, yes? As long as you get hoorays, you can be in the loop, but anything fails, you can break out of the loop. I can show you how to do that, or someone can show you how to do that. Yeah, you got it right. And then new line. Don't forget the new line. Or you can say endl, left shift endl now. Yeah. Right, and then you can exit 0. On the next line, you can say exit 0, and then you want to put the whole thing in curly braces because now there's two statements. After the if guess, at the end, you can put curly brace. Yeah, and then there you can say exit 0. Exit 0. Or return 0, whatever it is. Yeah, for now, exit 0. And again, exit is a function, so you call it with the parameter 0. Yeah, semicolon. Nice. You got to the space and all. That's what I usually do. Right? Enter, curly brace. Right? Else. Well, in fact, you don't need an else, but we'll put the else there right now. Right? So else. Else. In fact, why don't we do this? Okay? Branching statements, exercise for you. It'll work without the else, but you got to discuss in the forums. Why does it work even without the else? Yeah? Okay, so get rid of the else. Right? On the next line, go on to the next line. This is called, I think there's probably a name for these things in programming patterns, but you can actually omit the else in certain cases. And this is one of the cases where you can omit the else. Yeah. Okay. All right. So, yeah, and now you can say, see out, alas, you were not quite right. The right line, alas, yeah, alas, exclamation mark. Yeah, you were in, alas, you said, colon, space, yeah, and then left shift. What do you say? Guess endl, and then endl after that. Thank you for coding, Caesar. Okay, this is great. Okay, on the next line, yeah, see out, left shift, but I expected, colon, uppercase I expected. Oh, cool. And hey, that's really cool. Hey, line up really nicely, because now you can get the two lines. You know exactly what the difference is. Right. So space. Right. Now left shift, random sound line. Really cool. Yeah, I didn't expect you see, you get the two lines. You can, all right. Okay, cool. Endl after that. All right. Now, if you run this is actually a full game. The only thing that's missing is in a loop. So as long as you keep getting it right, it'll give you a new line every time. Right. And so that's all. All right. I'm going to try this. Oh, you got to clean up a bit more, but that's okay. Yet dot it's teal sweet hours. Oh my gosh. Oh yeah, you don't have enough spaces. You see that delight? Yeah. So you can work on those things later. In fact, I didn't read it properly this time. Sweet hours. Let me try and complete it. Oh, you're gonna run it again. Okay. Yeah. All right. Okay. Cool. I'm gonna remember this. So shall those blots that do with me remain. Okay, capitalize. You got it. Oh, and you're not accepting it on the next line. I see. All right. So this is the other thing you can do is after that prompt, you can go to the next line and ask the user to type it in on the next line, not on the same line, so that it'll look nicer. Yeah. So now I've forgotten. So shall. I've forgotten. Does anybody remember?
So shall those blots.
So shall the blots.
So shall those blots.
So shall those blots. Okay. So shall those blots remain.
That do with me.
Oh, that do with me remain. Okay. That do with me remain. Are you reading it out from somewhere? Who is this? Oh, you were actually reading it out from there. Oh, no, that's not fair. Okay. I was trying to remember. Okay. All right. Next time. Okay. Now hit enter. No, even that was wrong. Okay. So look. No, it's exactly the same. No, wait a sec. Exactly the same. No, I think there's one extra space somewhere. Go to that place where you print the two lines. Wait a sec. Guess random. One of them has an extra space. Which one has an extra space? You said, okay. Oh, I see. When you type, oh, I see. When you typed it, when you typed what I was saying or Roger was saying, you put a space there in front. That's why it didn't match. You got to be, identical up to white space too, just like in the quests. You can run it again, but this time let's try and clean up a bit more. I saw something that needed to be cleaned up. Run it again. This time I'll try. I'm going to remember it. Nobody, no cheating. Okay, no looking at the poem. Okay, so we're all going to remember. But do not so semicolon. I love thee in such sort. Okay, I got that. I got that. Okay, but all right, but do not so semicolon. I love thee in such sort. Is that right? Because it rhymed with the report later on. Right. So no spaces extra, no spaces. Oh yeah. That's the thing that I was talking about. You got to accept on the next line. Do not so semicolon. I love thee in such sort. Enter. Megan, welcome to class. Right. I didn't see you before. Hey, we got it right. Okay, we got it right. Okay, so now you got to play with this and say, as long as I keep getting it right, you stay in the while loop, while true, right? If you get it wrong, you say, alas, break out of the loop. So you get a chance to exercise and practice with break statements or continue statements or combinations of those, or just loop variables. So 5, 10 different ways in which you can break out of the while loop with this thing. You're going to put this in a while loop. This is your exercise for Reddit, things that you're going to do, share, right? For class demos. You're going to put this whole thing in a loop. It's super duper simple, right? All of you, or online too. Take this logic, put it in a loop, and the game should be such that it gives you a line. Remember it, 5 seconds. Type it in. If you got it right, you'll get a new line. 1 point. Okay? Got that line right too. 2 points, new line. You keep going. Or maybe double each time. 1 point, 2 point, 4 points, 8 points, and so on. Right? Because you got 10, 2 to the 10, maximum 10 to 2 to the, 10,024 points. You can't go like crazy with this, right? Because it's 10 lines. Oh, it's more than 10 lines. But still, 2 to the 20 is even a million, right? 2 to the 20 is a million. So you can get a maximum of, even with 20 lines on it, you can only get a million points. So yeah, you can keep doubling. You can keep doubling the points each time in the loop. You survive, right? If you're dead, that's the amount of loot you got. But if you're not dead, you can go on in the next round. But if you win the next round, you get double the number of loot. That's really cool, isn't it? You can put it in the loop. If you have any questions about how to do it in the loop, just ask me, Christopher, Pani, anyone, right? Even on Reddit, doesn't matter. Your challenge is to try and implement this in as many different ways as possible and knock yourself out with different kinds of for loops, while loops. You got to put it in a loop. It's got to be in a loop. You're going to get your, all your friends and acquaintances and brothers and sisters and relatives to play it, okay? And choose something, ask them. Oh, yeah, reading from a file. How much time do we got? And show you how to read from a file.
7.
Oh, it is time already?
Yeah, we got 7 minutes.
Okay, 7 minutes. All right. Super duper simple. You can actually look it up. I can read it if you want later on. If you want to read from a file, it's exactly the same as reading from CN, except before you start reading from file-in, FIN, right? So you want to create a variable called FIN, any variable, really, right? That variable, you're going to attach it to a file. There's one line you can use to attach to a file for reading. It's called ifstream. You got to include a file called #include fstream, file stream. Okay, that file, that library has all the functions that will read the file from the disk and turn it into a stream just like CN. And after that, you can interact with FIN just like you're interacting with CN. So you can open a file, and next class I can show you, right? 5 minutes. Open a file, read all the lines, one line at a time using getLine from the file. And each line you get, you stuff into a vector using pushback. And you get exactly the same vector, but from a file. Now, all you need to do in your main is to look at the argument. If it's given, oh, is there a file by that name? I'll look for the file, open the file, read all of that into my vector. That's all. Like 3 more lines. Okay. If you have any questions, you can ask in the Reddit, reach out to any of us, and we'll, walk you through this code. Because it's not Quest code, we can walk you through this code too. You can share your code, and you can share your code, right? You're doing this, you can share your code and say, hey, what am I doing wrong? Can someone fix it or do a version? We'll all be happy to do this. Hopefully not me, okay? Because I want more of you to take stabs at it.
Is that something that CS2B or CS2A?
2A.
The file in?
Oh yeah, 2A. I mean, I used to do this in 2A. It's super duper simple. It's like 5 minutes of class. 5 minutes of class. No, it's not part of any quests. And I don't think it is part of the CID issued by the state, okay, by the government. But it isn't part of the syllabus for some strange reason. It's part of the CID, okay? You're supposed to know about this. I think it's not part of the syllabus because it's so straightforward. It's like 5 lines. All you need know how to use see in and see out, yeah? And this library only gives you an opportunity to turn files into something like see in and see out, that's all. So you learn how to do this and then say, well, you can turn the file into this, that's all. That's why it's not part of the syllabus. It's so simple. We can talk about it, right? We can discuss on the Reddit and we can say this is how you do it on Reddit. I don't think it's there in the modules. There's something in the text. There's something in the text that talks about this, I think. Please Google. It's easier. Please Google say how to read from a file stream. It'll tell you. That's all, okay? And then put it in a loop. And I hope to see, and also you got to clean it up, okay? Like this sentence coming in the end. It's easier said, you'll take it to the next line and all. So clean it up, generate your own version, and create your own flavor of rewards, right? Because one could be one point for each survival. The next, another strategy could be every time you survive, you get twice the number of points as the previous time, because surviving is hard. You got to keep remembering, right? And then maybe you'll even come up with a version that says, I'm going to give 2 lines at a time for experts, right? So you got to, so all of these things you can do. But this is just a basic version, right? Just to show you what's possible. That's really what, most teachers, the job of the teacher is not to show you to solve the whole, eat the whole cake, but show you, hey, this is a really tasty cake, all right? So it's just a small bite. And then it's up to you guys, okay? So you can just take it, have a crack at it and do various versions. It's bound to be fun, okay? And like I said, practice is key to mastery. And it just involves lots and lots of hours. Doesn't matter, okay? What I don't believe, other people may tell you otherwise. Understanding is different, okay? Practice is key. You got to keep at it hours and hours and encounter many different ways of failing, which people don't do. If you understand things, you won't fail because you'll understand one way of doing it and say that's correct, right? But if you want to fail, you got to do it because you'll know that, well, I understood it, but there's some corner case and there's millions of corner cases. And so you got to keep trying what you already understand many, many times so that you will be exposed to the different ways in which you can fail so that you won't fail in public. Yeah. And so that is the trick of mastering, through practice. And the goal of the class is not to tell you this is how you do it, but just to show you, here is one small piece for you, one small musical phrase, right? Now you can take it and explore it to your heart's content by playing around with it. Lengthen this note, shorten that note, throw in a chord. All these things, you experiment and see what it sounds like. And exactly the same thing here, okay? I'm giving you a basic framework here. And this is something that does something mildly interesting, okay? Which means it has a lot of scope for customization. So you're going to take that and say, well, my teacher has given me a boring task. No, right? My teacher has actually given me a mildly interesting task, okay? I'm not giving you a boring homework and say, do this, And so this is interesting. And so now you can say, I'm going to try and play with this code because it's not boring. So hopefully it's not boring, okay? So do this. And people have been taking advantage of these things, Raj, Akash, and more of you should just create your own versions. It doesn't have to be like this, right? Like Pig Latin was not at all any of the conversion things that we talked about. So you can have your own idea of how you can present something. It doesn't even have to be poem lines, right? Or you knock yourself out. The idea is to have fun. And my job is just to say, wait, there's one way to have fun, but students can find millions of ways to have fun, okay? I just need to show them one. And because you got a lot of time, a lot of energy to just noodle on these things. So you'll find much better ways to share with other students, okay? Not because I can only share, so this is the one way, but when students saw other people saw, Raj's or Akash's post and other people, Vivian's post, they knew, oh, there's all these other things I can do too, right? Which I didn't cover in class. That is really, students always listen more, I think, in my experience, to other students than to the teachers, okay? Because they always, I think, teachers, they say, oh, teachers, they're doing a job, and saying, oh, this is what you got to learn, and so on and so forth. So, it's okay. They value what we say, but if a student says something, I think it has more weight because they know that it's experience. So do share good experiences. Don't only share bad experiences. People only share bad experiences most of the time. Don't do this class, it's hard. No, it's actually a good class. Okay, do it and also put your soul into it. All right, thank you all for this class. I hope this was this useful? We covered one new concept, arrays. We got one more class to talk about arrays. We'll try and take this with array kinds of problems. Maybe we'll do a numerical problem next time, okay, with arrays. I don't know. Or maybe we'll just do this, take this to the next one. We'll think of some ideas. Okay, thank you all so much. I'll see you on Thursday, okay? It's not supposed to rain, so I think we'll be in class.
See you.